Hi, hello, and welcome to How to Bring Up SYSGO's PikeOS on RISC-V based PolarFire SoC FPGAs. My name's Alicia, and I would like to pass it over to our presenter for today's session, Stephen Wagner, an R&T engineer from SYSGO.
Yeah, thank you and welcome everybody. So my name is Stefan Wagner. I'm a project engineer for the Research and Technology department at SYSGO. And today I will show you how to bring up PikeOS on the PolarFire board. I will give some information about SYSGO as a company and then continue with our main product PikeOS and show in a live demonstration how to set up a project for application development in our integrated development environment CODEO. So let me start with a brief introduction of SYSGO. We are a leading European supplier for operating systems, for embedded systems, and headquartered in Germany with sites in France, Czech Republic, and the UK. We started about 30 years ago with services for embedded devices and developed from that background our own operating system with a development environment targeted to system and application designers. With our products, we mostly are targeting safety and security of embedded applications. And since 2012, we are part of the Thales Group. We offer products and solutions such as our main product PikeOS, which is a real-time operating system with hypervisor functionality that can be certified up to the highest levels of safety and security in various industries. And with ELinOS, we offer an own powerful Linux distribution, which is optimized for embedded devices and focuses on security. This helping then software developers to save time and cost. We also provide platforms for software development and certification kits and develop board support packages. Here we can see an overview of 5 pillars that make SYSGO the #1 choice for customers. So we offer a broad ecosystem of over 60 software and hardware partners, which result in robust products that are ITAR-free, so that means we don't have export restrictions. SYSGO has been certified to fulfill the quality management and information security management standards, and our products are widely known and used in various industries. We are offering powerful technologies for components and configuration possibilities in projects. We have safety certification kits available for industries such as avionics, railway, or automotive. And for cybersecurity, we have certified according to common criteria EAL 5+. And we support customers with consulting services and trainings and also offer long-term support, of course, for all of our products. Okay, so what is PikeOS? PikeOS is a real-time operating system with a Type 1 hypervisor with strong performance in separation of partitions and applications. PikeOS sits on top of the hardware and enables developers to put other technologies on top of it. And PikeOS then guarantees the safety and security of the complete system here. Our technology allows to have various applications with different levels of safety and or security criticality side by side on top of the hardware. And the applications and the partitions are strictly isolated and protected from each other. It's even possible to load a whole operating system like Linux, Android, or even Windows on some architectures into such a VM. And this can be executed without interfering the other operating systems on the system. We support the most popular hardware platforms like x86, ARM, PowerPC, RISC-V, and Spark Leon, for example. And our products are available for microcontrollers with memory protection unit, MPU, and also for systems with a memory management unit, the MMU. So you have a freedom of choice for your projects, which hardware to use. We offer fast time to market with this approach. You can use it for hardware consolidation or load some legacy applications into different partitions on one hardware. And it's also easy to integrate and configure third-party applications into a system and configure them according to the needs of the project. And PikeOS is fully developed and built in Europe and has therefore no export restrictions. So here we have an overview of the PikeOS core offerings. We can highlight the safe and secure separation kernel and the hypervisor where different applications can run on. Also operating systems or runtime environments and APIs. Our certification kits are available for industries with need for the highest levels of safety and security standards for critical applications. PikeOS provides a modular certifiable framework. PikeOS system software, the separation kernel, and the architecture support packages are available as pre-certified components. And the platform support package and the user applications are usually certified in the context of a project. We also have certifiable APIs available to develop applications like POSIX, ARINC 653, or the PikeOS native API. And we also provide several certifiable components like an IP stack, file systems, and the math library. We provide certification kits, which include all the necessary artifacts and documentation. And of course, we provide support for customers to fulfill the wider system certification requirements. PikeOS supports multi-core systems. So you can use symmetric multiprocessing here on a multi-core system. You have one instance of PikeOS controlling all processor cores, and then assigning this according to the time scheduling to different partitions that you can define which partition shall execute on which core at which point in time. And it's also possible to use an asymmetric multiprocessing, that you have one instance of PikeOS running on each core. And our certification kits for different safety and security standards. Coming to RISC-V, PikeOS is ported here to boards with an RV64 cores. We support multi-core processors here and have also support for QEMU as a hardware emulator, that you don't need an actual board to start development of applications. And for the PolarFire board, the board support package of PikeOS runs on U54 cores. We have support for the serial interface and the Ethernet interface, and support a custom machine mode manager. Short overview of our documentation. So we have for all relevant aspects documentation available, highlighting here the PikeOS user manual describing all the basic concepts and the tutorials with step-by-step instructions how to set up projects and use the different concepts. For RISC-V, PikeOS requires RV64G cores support from the cores, and we support all the extensions which are defined by that. We have implemented a 64-bit support with a page-based 39-bit virtual memory system. The operating system is running in supervisor mode, and the applications are running in user mode. PikeOS also supports the compressed instruction extensions, and we have support for the PikeOS native personality, the ARINC 653 and POSIX, and have a proprietary supervision binary interface implementation. Then coming to our integrated development environment, CODEO. This is Eclipse-based and provides a lot of helpers and wizards for configuration and system management here, that you can easily and fast set up systems. So we have tools for a guided configuration of a system. We have remote debugging, that you can debug applications which are running on top of PikeOS. We have tools for target monitoring, that you can see which partitions are in which state, or which is the state of different communication channels. We have a possibility for remote application deployment during development. We have tools for timing analysis of a system, and all the application development features are completely integrated. Here's a screenshot. We will see this in the live presentation, highlighting some parts here. So we see, for example, here a screenshot of a special editor for setting up shared memory and defining the access rights for shared memory objects. Here one special editor to define and set up the communication channels between partitions. Here's a special editor to set up the time schedules on a processor core base, and also editors to access the attributes of the XML code, that you don't have to handle XML code with a text editor. And of course, our Linux distribution is also fully integrated into CODEO. And now we will see a live demo. Okay, so here we are in our development environment, CODEO. I want to show you now the steps how to build a small application and execute it on the PolarFire SoC. So I create a new PikeOS project. First of all, of course, we need the configuration for the board and the partitioning in the system. We call this integration projects. So I clone an integration project. On my board, we have several demo projects which we can use as starting point. I start with a simple PikeOS native demo, which has one partition for a PikeOS native application, and I select board support package for the PolarFire board. I click here on Finish, that the project is created. Now we have the configuration of the board. We see here the configuration for the partition. So we have one application partition of type PikeOS native. And here is the configuration with all the settings for the board support package for the BSP, with all the drivers which are needed, serial network, and all the configuration which is needed there. Of course, then we need an application which will be executed in the partition. So I will create a new PikeOS project. Now I use an application project of type PikeOS native. Again, we have some demo projects here. I will use for demonstration the Hello World example. And for the application project, I only have to select the toolchain which is needed to compile the application, prepare the application project. Now I can, for example, look at the source code here. So we see just a little Hello World message. I can change the output to Hello PolarFire, save it, and then I can just say make install in the application project, which compiles the application and installs it in a place that the integration project can reference it. Of course, in the integration project, here's the configuration. I now have to select which binary to execute in that partition. I use the one we have generated. The name is okay, the same here. I save this configuration, and then I can generate the boot image. So now all the needed binaries and the kernel are prepared and put into the boot image. And with make install, I copy the boot image to the place where the TFTP server expects it, that I can download it from the target. So I have now here two telnet connections to the different serial interfaces of the board. One is for the firmware output and one is for the bootloader. So I now start board. We see now the board is starting up. Here is the message, the output from the firmware. Here we see the bootloader. Okay, here we see the bootloader. So I now load the binary, the new boot image via TFTP boot via network and start it. Now the DTB are transferred via network, and now PikeOS has started. We see the boot messages of the PikeOS kernel, and here the output of our application. Hello PolarFire and some output. Okay, so the key takeaways are that Microchip and SYSGO can jointly address new or critical use cases. Our integrated technology can pave the road to growth. And SYSGO's PikeOS on the PolarFire board can be used as starting point for mission-critical projects with a quick start for the BSP software and project configuration, and the customers can then focus on the application development.
Great. Thank you, Stefan, for your great presentation, and thank you to our audience for attending today's session. Thank you, and have a great day.
Thank you.